Welcome to clickmyproject.com. Let's see the discussion of the paper Boosting Color Feature Selection for Color Face Recognition. In this paper, we introduce a new color face recognition method that effectively uses boosting learning as color component feature selection framework. That is, we have to select best set of color component features from various color spaces. For the selection of optimal set of color component features, we prefer Addons framework. The selected features are combined together using weighted feature fusion scheme. After getting the feature subset, then we implement nearest neighbor classification algorithm for recognition. In general, the Addons framework is used at the classifier stage, but in this paper, the role of Addons is for selecting best features. That is nothing but it is the feature selection. Existing color face recognition methods were restricted to use 2 or 3 color spaces, but in our proposed system, there is no limitation upon the number of color spaces used for representation. With these two new ideas, we can improve the face recognition rate. This is the DFT of this proposed system. Here we introduce the training data set. Now this training data set, it contains the whole database images that we are going to train it. And afterwards we may select one of them as the test image. The next block here introduced is learning set construction. After explaining the Addons algorithm, we may see this block in detail. Now we go for the color space conversion block. Totally here we use 7 color space representations for the given test image. That are RGB, YCBCR, YIQ, HSV, LAB, CID and then YUV. Followed by this color space conversion, the features will be extracted by means of PCA. Totally, we have 21 color components in our hand. So, the 21 color space representations are given as input to the PCA algorithm. PCA is nothing but the dimensionality reduction algorithm. The output of PCA is nothing but the feature set of the given input image. The next one is the selection criteria and then followed by the best feature determination and then the selection of FR learner. These 3 blocks come under the explanation of Addons framework. In the initial stage of Addons, random weights are initialized. Then the weights are updated upon the selection criteria. Finally, the best features are selected from that. So the result of Addons algorithm is nothing but the division of strong learner and then weak learner. The weak learners corresponding to that of training samples are once again fed back to the input for the construction of this new learning set. This process is repeated furthermore to obtain the optimal set of features. This is the explanation of this DFT. Now let me explain you the demo of this proposed system. Select the main.m file and then run it. The guy will be look like this. And select the file option from the menu bar. Under that, open. You will be shown a file dialog window. Inside that, testing set folder is present. You have to select one of the image. Now I'm selecting the 5th image. Then do the color space conversions. The first one is RGB. The 3 color components such as red, green and then blue will be displayed you. And then YCBCR followed by YIQ. Then HSV, hue saturation value, then LAB, CID, YUV. So 7 color space conversions we have done up to this. Then we extract the features from the color components that are extracted before that. So press the PCA option here. A message box will be displayed to indicate the completion of that feature extraction process. Press OK to this. Now you press Add a Boost option for the selection of feature subset. It will take some time for the execution of that Add a Boost framework. You will be shown a graph like this, figure 1. Now the first one is the training data. It is the feature space projection of all the training set of images. The second one, it displays the Add a Boost model that is obtained from the training data. The third one is the classification error that is introduced during the training part of that Add a Boost framework. And final one is nothing but the classification, that is strong and weak learner classification done with the help of the Add a Boost model. Press OK to this message box. Now do the nearest neighbor recognition algorithm. Now this is the test image selected by the user, and this is the corresponding recognized image taken from the training set of images. Now this is the feature space projection display of the whole training set of images and the test image also. And you can view the features of whole training set of images by pressing this button, Show Features, and the selected, that means the optimal set of features that can be viewed by selecting this button, Boosted Features. Then finally, you see the classifier performance by selecting this option. And this is the ROC representation for this algorithm, that is receiver operating characteristic curve. It is a inverted L-shaped curve. So the area under the curve is maximum. It shows that we achieved the better face recognition rate. Finally, we observe the recognition rate and all the things. We may come to the conclusion we got the face recognition rate in a successful way. Thank you.